This is Mission Control Houston. We want to welcome you to Space Station Live. It is Monday, August 26, 2013. This is a live view inside the flight control room here at the Johnson Space Center. This team today is being led by Flight Director Ron Spencer. He is sitting there in the center console on the right-hand side of the screen. Sitting beside him is today's Capcom, David St. Jacques from the Canadian Space Agency. He'll be the one talking with the crew on board the orbiting complex. The Expedition 36 crew includes Commander Pavel Vinogradov, who is sitting there second from the left. On the far left is Alexander Mazurkin. There in the center screen is Chris Cassidy, NASA astronaut. And right beside him is Luca Parmitano from the Italian Space Agency. Also Fyodor Yurchikhin, second from the right, and NASA astronaut Karen Nyberg there on the far right-hand side. The crew today is working throughout the entire space station on a variety of different maintenance and science tasks. Pavel Vinogradov has been transferring some water from the European Space Agency's automated transfer vehicle into the Russian segment of the ISS. This is done always. The ATV brings up quite a bit of cargo and supplies and also some water for the crew, so they're transferring that over into the tanks and doing some leak checks on the ATV once that has been completed later today. Alexander Mazurkin is working on some routine maintenance inside the Russian segment that is taking up basically his morning and his afternoon. He'll have some exercise later on today, but he has a fairly light day. Fyodor Yurchikhin has got a ham radio session with a school in the Ukraine. Both Yurchikhin and Mazurkin coming off a spacewalk last Thursday that lasted 5 hours and 58 minutes. That was the second spacewalk for these two in as many weeks. They took care of a number of tasks outside the station. They removed a space laser communication system from the hull of the Zvezda service module. They installed a pointing platform on which a small optical telescope will be installed on a future Russian spacewalk. And they also inspected the antennas on the Zvezda to ensure that they are fastened securely after one of the covers became dislodged and floated off into space. Here just a few days ago, that video is on the internet that Chris Cassidy saw that object floating away. The ground teams did take a look at that cover. Basically, it's part of the ATV's rendezvous system that comes up toward the back end of the Russian segment. They deduced that the specific antenna that cover came off of is of no concern, so they're not worried about it, but they wanted to make sure that all the other antenna covers were securely fastened. And, of course, they did take a look to make sure that that one cover that did float away was not going to pose any sort of threat to the International Space Station, but that thing moved away fairly quickly and got out of the way of the space station, and there is no worry about that. Chris Cassidy is working on finishing up some work in the Japanese HTV. Right now there's several different cargo vehicles docked to the International Space Station. We just mentioned the European ATV. The Japanese HTV is over on the U.S. segment. It brought up several tons of supplies a couple of weeks ago. There's a layout of the current station. Right now you see HTV-4 down there on the bottom side of the Harmony node. You see the Soyuz 35 as well as the Progress 52. ATV-4 is back there at the back of the Russian segment, and the Soyuz 34 up there on top on the Poisk module. But Chris is going to be working on actually scavenging some of the light bulbs inside HTV, which sounds sort of unusual, but obviously there are lights inside HTV. HTV is going to be deorbited and burned up here in a few days, so what the crew typically does anytime one of these visiting vehicles comes up that's going to be destroyed at the end of its mission, they take the light bulbs out because they can actually use those inside the space station itself. He's also working on an experiment called the Sphere's Rings today. Everybody who has ever watched Space Station Live knows about the Spheres experiment. They ran this experiment last week, and he's going to continue powering up and doing some training on this fairly cool experiment that takes a look at how satellites free float and fly in formation up in space. This specific Sphere's Rings experiment also looks at formation flying and also some wireless power transfer to where two satellites could actually swap power with each other without actually touching. This particular experiment, the Sphere's Rings, is run out of DARPA as well as the University of Maryland. Luca Parmitano working on setting up the combustion integrated rack. That experiment continues right now as we go on the air. He set that up so that the ground teams both here in Texas and in Alabama can run that experiment. The ground teams are taking a look at the inside of that particular combustion integrated rack, which you see the full size of it there as we speak. He's also taking some water samples throughout the U.S. segment today. They always do that to take a look and make sure that the water is acceptable and that there's nothing growing in it. Karen Nyberg finally working on InSpace 3. This takes a look at fluids that change properties based on magnetic fields. These fluids have certain things called colloids inside them, which is basically some particles that whenever you add a magnet to it, that actual fluid can become solid. It can change characteristics. This has important implications on possibly brake systems here on Earth in your car and trucks, something like that. Also robotics. These kind of colloids could also be used in bridges and buildings to help them weather through earthquakes or items of that nature. She's also transferring some items from the HTV that'll take up later on this afternoon. The ground team's also working today to work on some robotics. They're going to stow the special purpose dexterous manipulator, or Dexter, as we call them, later on today. And then they're going to take the Canadarm2, the station's robotic arm, and walk off to a different part of the station. The exposed pallet that came up on HTV, which is sort of the center section of that cargo vehicle that brought up unpressurized cargo, is currently attached to the forward end of the Kibo module on the exposed facility that's sort of the front porch of Kibo. It's going to be returned, and that tray is going to be slid back into the HTV coming up on Friday. And then HTV is actually going to be unberthed and released on September the 4th. It'll hang out in space for a few days, and it'll be deorbited coming up on September the 7th. Another important note, departure preps continue for Chris Cassidy and his fellow crew members Alexander Mazurkin and Pavel Vinogradov. Their time in space coming up to an end here in just a few weeks. They launched back in March and headed up to the International Space Station. They're actually going to be coming home, coming up on September the 10th U.S. time. Of course, we'll have live coverage of that here on NASA television as his crew lands down in Kazakhstan, the same country in which they launched from. But they've got about an hour of departure preparations on board the space station today. Of course, as one crew goes home, another one gets ready to come up. Mike Hopkins and his fellow crew members, Oleg Kotov and Sergei Ryazansky, are reviewing procedures today at the Gagarin Cosmonaut Training Center in Star City, Russia, for next week's final qualification simulations. They basically have some tests they have to go through, and they're getting ready to launch coming up at the end of September. And also with that in mind, we want to remind you that we've got a crew news conference coming up with Expedition 38 and 39 coming up at 1 p.m. Central Time, 2 p.m. Eastern Time here on NASA television. That'll be on Wednesday.
Moscow station on SG-1. Go ahead, Pavel. Sasha, the radiogram states that I need to perform a leak check of the shell of Rebecca. And do the specialists know for sure that there is no water there? But what if water comes out? What am I going to do? All right, let me ask them. I have a proposal. Okay, I'm going to... So what's the proposal? I have two empty containers. One, I believe, is 1012 and 1090. Maybe I should use one there and maybe transfer some water. Should there be any remaining water in that container? And then I can do the lecture. Oh, okay. Checking. So you said 1013 and 1098? No, 1090, 1090. That's an empty one. So it's 1013 and 1090. Copy, Pavel. Let me check with the specialist.
That was the Russian flight control team just outside of Moscow talking with their counterparts on board the International Space Station. As we mentioned, Pavel Vinogradov has been working today to transfer some water from the ATV. That is a European automated transfer vehicle that's on the back end of the Russian segment. So he's been calling down to the ground teams to let them know what he's working on, and they are guiding him through the process for that. There's a look at the graphic again of the space station, ATV-4 there on the back end. The crew is pretty much wrapped up transferring the cargo from ATV over into the station. Of course, I got to figure out where all those pieces of cargo go. Inventory management is incredibly important on board the space station, both with ATV and HTV, and even the smaller vehicles like the Progress and the SpaceX Dragon. Here's a live look outside the International Space Station, currently on the northwest coast of South America, crossing up toward the northeast. Its altitude right now 255 miles above the Earth.
МКС СУП Москвы в канале СГ.
ISS Moscow on SG-1.
На связи, Саша.
Go ahead, Sasha.
Саш, ну вот для Паши можно емкость 1090 тогда использовать.
For Pavel, could you please relay that he can use an empty container 1090? Copy 1090. Yes, that is correct.
As we continue to take a live look outside the International Space Station, you are getting a good view there of the station's robotic arm there at the top left-hand side of the screen. And the station's truss structure there on the right-hand side. That's the backbone of the station. This conversation we're listening to is between the Russian ground team outside of Moscow and Pavel Vinogradov on board the space station. He's been working on the ATV, transferring some water from the cargo craft over into the Russian segment.
Хорошо, ну тогда дальше идем по проверке герметичности.
Copy all. Then we'll
Паша, последняя насколько
continue
заполнилась вот ЕДВ?
with the leak check. And what was the level, the container for the last one that you filled?
Саш, слушаешь?
Sasha, do you read me?
Достаточно воздуха, меньше 50%.
Yes, I'm looking at percentage. Maybe 1/3 of the container is
А
full.
номер этой вот
1/3.
какой?
What is the number for the
1063.
for that container? 1063.
Хорошо, принято.
Copy 1063.
От атмосферной влаги. Паш, ну и дальше можно 4,
Павел?
4.1.3 выполнять, проверка герметичности. 4.3.1.
So you are go to perform the next step 431, that is the leak check, copy, and work.
This is Session Luca on 2 for water analysis.
Yes, Luca, go ahead on 2.
Just a question on the restow. Item 30 on the restow says microbial capture device quad 4. And for item 32, I also have 4 coliform detection bag. And did I assume wrong that I was supposed to analyze all of them?
Checking. And Luca, on 2, you were right in your assumptions. Needed to do all 4 for both the microbial capture device and the coliform detection packet.
Okay, so there should be 4 bags inside the incubation bag.
Yes, that's right.
Copy.
Here's live view of Karen Nyberg on board the International Space Station. She has been working inside the complex today on a few different things. She's got the HTV cargo operations going on, basically moving some items back into the HTV as it gets ready to end its mission coming up on September the 4th on board the International Space Station. She's also been running an experiment called InSpace 3 that we talked about at the top of the broadcast. This is an interesting experiment that takes a look at fluids that have different things called colloids inside them. There's a few different flavors of this colloid type experiment, but this particular one takes a look at how different colloids, or these structures that are inside these fluids, react to magnets. Because basically you can change the characteristic of the fluid by applying a magnetic field to it. It basically solidifies. A lot of these experiments on board the space station take a look at this phenomena because they don't have to run into sedimentation like you do here on Earth. So you can just imagine if you've got a fluid that has different pieces of sediment inside of it, gravity tends to wreak havoc on it, and it can sort of settle out, and you don't really get the product that you're looking for. So up in space, you don't have to worry about that. So the scientists can study these colloids in sort of their pure form as they stay scattered throughout the fluid, apply this magnetic field to it, and watch what happens. And the reason this experiment matters is because it has direct implications here on Earth in things like brake systems and bridges and buildings, like we talked about at the top of the broadcast. You can imagine if you could build a building or a bridge with this sort of fluid built into the foundation of it, it could withstand things like earthquakes or other sort of natural occurring phenomena. So it's yet another example of how things up in space and the lack of gravity can have direct impacts here on Earth. This is a look, looks like a bunch of green blobs, but this is a look up close at the colloids inside the structures. Doesn't look like much, but you can tell that it is sort of scattered evenly throughout there. Of course, if you would like to learn more about InSpace 3, read more about it, and the researchers that are behind it, just log on to the NASA website, www.nasa.gov/station. It's www.nasa.gov/station. You can take a look at that landing page there and find out what the crew is up to every day. If you look on the left-hand side, you see research and technology. Just click on that section, and you can take a look at all the different experiments, either by expedition, so you can see what Karen and Chris and the rest of the crew have been up to while they've been up on board the station, as well as previous expeditions, as well as future expeditions. You can also take a look at it by topic. So if you're interested in what all kinds of biology experiments that the crew works on, you can categorize it that way, or you can look it up alphabetically. So you can slice and dice it any way you want to. NASA.gov/station. This is a look inside the combustion integrated rack. Probably one of the more visual of all the experiments on board the space station. But you see the two needles there, they will start to form a bubble. What this does is take a look at different fluids, different gases inside the space station itself. You will see that bubble grow here in just a few seconds. In between those two needles, it'll get bigger and bigger. They'll probably zoom into it, and then those two things you see on either side are igniters. Basically, they will blow it up right here, and they take a look at how these things burn. There's a fairly spectacular one that happened right before we came on the air that sort of continued burning in small little parts and almost looked like a little mini star sort of blowing up. But we'll continue to take a look at this and see if they can run it again for us. This combustion integrator rack that's on board the space station it's pretty big. It's about the size of a phone booth, as you can see that liquid there being expanded. But it's got a 100-liter combustion chamber surrounded by optical and other diagnostic packages, including a gas chromatograph, basically some scientific equipment that can analyze how these items burn. But keep your eye on the screen, because when they ignite these, it happens pretty quickly. Those two needles on either side continuing to increase the size of this fuel droplet you see there in the center of the screen. This should be ignited here shortly by the two igniters you see at the top left and bottom right side. But if you keep your eye on the center of the screen, once this thing ignites, it should be some fairly dramatic video as this experiment on board the space station continues inside the combustion integrated rack. So the igniters do their job, almost looking like a planet there forming in the middle of the screen, but this is just some fuel on board the space station that has just been ignited. So the ground team's now taking a look at exactly how it burns. Of course, things burn quite a bit differently in space than they do here on the ground. Again, the combustion integrated rack, a core part of the International Space Station. If you would like to learn more about that specific facility, just log on to the NASA website, nasa.gov/station. You can do a search for it and to take a look at all the other experiments that that particular facility houses there on board the orbiting complex. This is Mission Control Houston. We've been talking quite a bit today during our show about cargo operations on board the International Space Station with all the activities surrounding the Japanese HTV cargo vehicle that is on the U.S. segment, as well as the European Automated Transfer Vehicle, ATV. There's also some Russian Progress vehicles up there on board the station now, so different nations and their cargo vehicles currently attached to the station. Of course, the United States and NASA has had the Commercial Orbital Transportation Services program that started toward the end of the shuttle era to take a look at how U.S. companies could partner with NASA to create 2 brand new cargo vehicles that carry the U.S. flag that will be flying up to the International Space Station. Of course, this first company, SpaceX, started with the COTS program back in 2006, successfully flew some test missions up to the station, and has been running regular cargo flights ever since then. Orbital Sciences Corporation, which was the second company that took part in the Commercial Orbital Transportation Services program, started in 2008, and they are getting ready to test out their vehicle as well. They had a successful test flight this past spring. Preparations are underway right now at the Wallops Flight Facility for an upcoming test flight coming up in the middle of September. Orbital will be flying its Cygnus cargo vehicle up to the International Space Station to do a test flight, and then once that is successful, they will resume cargo flights just like SpaceX up to the International Space Station. We're going to take a look now at an overview of this project, the COTS program, as well as what's ahead for this test flight and the unique vehicle that is Cygnus.
With a half-century of spaceflight experience already in hand, America's space program is now pushing ahead on parallel paths, revolutionary and complementary paths. On one, NASA is building a space launch system and Orion spacecraft to carry astronauts farther from Earth than we've ever gone before, to an asteroid and eventually to Mars. On the other path, NASA is leaning on American-based private companies to help supply our orbiting laboratory, the International Space Station. As the Space Shuttle era came to a close, NASA knew it needed help to supply the station with tons of cargo every year and looked to the private sector.
How can we partner with industry? How can NASA be a partner with commercial industry and take advantage of the ingenuity and innovation that exists in American industry, as well as the entrepreneurial spirit to develop these new capabilities, just like any new product can be brought to market?
The answer was the Commercial Orbital Transportation Services program. Rather than NASA deciding on a spacecraft design down to the nuts and bolts, it made seed money available to private industry to develop their own cargo ships that could carry supplies to the space station, where human crews had been working for more than a dozen years. California-based SpaceX won its COTS agreement in 2006. Its Dragon spacecraft successfully performed a test flight in May 2012 and completed its first fully operational mission late in the year. SpaceX flights continue each year, taking tons of supplies and science up to the station, and just as importantly, returning science experiments back to Earth for study. Now, Virginia-based Orbital Sciences Corporation, which won its COTS agreement in 2008, is about to join the club with its Cygnus spacecraft. After Orbital performs a Cygnus test flight to the station, it too will begin flying routine delivery flights to the orbiting complex.
That will be the final milestone in what we call the Commercial Orbital Transportation System Space Act Agreement that will allow us to transition from that phase of the program into an actual contract with NASA to deliver cargo over 8 missions in about 4 years to the International Space Station.
Cygnus rides to orbit on the Antares, a 2-stage launch vehicle designed to provide reliable access to low Earth orbit for payloads of more than 5,000 kilograms. Its design incorporates components from leading global suppliers and uses subsystems that are already deployed successfully on Orbital's other rockets, the Pegasus, Taurus, and Minotaur launch vehicles that have been flying for years.
But Antares will serve a much broader market than just the space station logistics functions. It will also be used by civil and national security customers in the governmental market, as well as commercial satellite operators.
The Cygnus Advanced Maneuvering Spacecraft, consisting of a service module and a pressurized cargo module, also incorporates elements from flight-proven systems flown by Orbital and its partners. The service module avionics systems are from Orbital's LeoStar and GeoStar satellite lines. The propulsion and solar power systems from the GeoStar communications satellites. The pressurized cargo module is based on the multi-purpose logistics module by Thales Alenia Space, which built the cargo modules that carried supplies to the station 11 times, riding in the payload bay of the space shuttles. With a pressurized volume of nearly 19 cubic meters, Cygnus can deliver a total cargo mass of 2,000 kilograms.
Without the ability to take cargo, you won't be able to keep the station operating as a viable research platform, or even keep the crew there and keep them fed and clothed and all the things that anybody on an outpost would need. And that's really where they are, is on an outpost. So having that lifeline to Earth is very, very important.
Orbital will launch the Antares rocket and Cygnus cargo craft from NASA's Wallops Flight Facility in Virginia, thus opening a new commercial spaceport and strengthening the American commercial launch industry's role in the new future of spaceflight. As SpaceX and Orbital ramp up their supply flights, the International Space Station will continue to serve as our home in space and the site of the scientific discoveries that will allow humankind to venture beyond low Earth orbit, to explore farther from Earth than we've ever been before.
So again, that's a look at Orbital Sciences and their upcoming Cygnus flight up to the International Space Station. As of right now, that flight is targeted for no earlier than September the 17th. But if all goes according to plan, Orbital should be sending its Cygnus up to the International Space Station. If they launch on the 17th or sometime around that time, the actual rendezvous with the space station should take place around September 22nd. That is the targeted date. But it should be performing some test maneuvers, testing out its systems, much in the same way that SpaceX did. And then it'll rendezvous, and the crew will be grappling it with the station's robotic arm and installing it on the bottom side of the Harmony module, the exact same spot where the HTV currently is attached. We're looking down into that now as Karen Nyberg works on moving some cargo back into HTV and cleaning it out of the things that it brought up, packing it full of the trash that's going to be coming back home.
Nasha?
But they'll be shutting the hatch on that and sending HTV on its way on September the 4th and getting ready for Orbital to come up with Cygnus a couple of weeks later.
So we were talking to Mikhail. So Mikhail was calling me?
Нет, Михаил
No.
какой-то из Крыма. Я с ним
Well, a certain Mikhail
вызывает. Думаю, где же еще?
was talking from the Crimea, and there was nobody else.
Нет, а с теми, с кем
And the people that I wanted to talk to and I needed to talk to, I didn't talk to.
Хорошо.
All right, copy.
Слушай, ну
Understand further?
Вы приглашали там специалиста, то есть вот
We also invited a specialist, and Mr. Rudkov from Victor from GCTC called us, and he said that most likely Mr. Krukov will come tomorrow, and he'll be able to help you. All right.
Пока у меня все.
That's all I've got. Thank you.
Сейчас, Федор, секунду. Вам радиограмму послать?
Further, please stand by. We
3:11.
have sent you a radiogram 3311. That was at your request.
Да, по восстановлению настроек радиолюбителя.
Right, 3311. That's to restore the capabilities. Copy.
Есть.
Yes, I confirm we have received it.
Всего
Thank you.
Хорошо, принято.
Appreciated. Copy.
The Russian ground team continuing to talk with Pavel Vinogradov aboard the International Space Station. Right now, the orbiting complex is over the Middle East and heading down toward the southeast, heading off into orbital night as we speak.
The completion of the International Space Station heralded a shift in focus from current capabilities in human spaceflight to future possibilities. The lessons we've learned working on station have expanded the realm of possible achievements in human health, education, Earth observation, and exploration beyond low Earth orbit.
We're doing a lot of really interesting things that are going to benefit us in that next phase of exploration. Obviously, we're most interested in understanding the human body in zero gravity because we want to go beyond low Earth orbit and explore, and in order to do that effectively, we have to understand what is happening to our bodies.
The unique microgravity environment aboard ISS enables astronauts to conduct advanced studies of human anatomy and physiology that cannot be performed on Earth. These studies range from microscopic biology to the effects of full-body exercises. In the Kibo laboratory, astronauts grow protein crystals that are unaffected by the shaping force of gravity. By studying the resulting structure, dimension, and properties of these protein crystals, scientists can uncover a wealth of information about the human body. One protein crystal has helped scientists understand what causes certain allergic reactions, while another facilitates treatments for diseases like muscular dystrophy. With over 100,000 different proteins in the human body, the wide range of potential biomedical discoveries will be a fundamental asset in helping us understand the microscopic mechanisms of life. In addition to the results of health-based experiments, the advanced tools and equipment developed for ISS also have applications here on Earth. The sensitive, precise technology developed by the Canadian Space Agency for a series of robotic arms has been adapted to perform delicate surgeries here on Earth. Capable of working inside an MRI machine, the NeuroArm makes it possible for surgeons to operate on a patient's brain without the risk of tremors from a human hand. Engineered and constructed entirely from non-metallic parts, the NeuroArm permits precision surgical movements with absolutely no magnetic effects on the arm or interference with the MRI device. This same approach is being used to develop an even more advanced robotic surgical arm called KidsArm for use on the delicate tissues of small children and babies. The ever-changing technological landscape of education now makes it possible to connect students to space via ISS.
The space station is having an amazing educational impact in our country. We recently found that over 40 million students had participated in an education demonstration, an interview with an astronaut, or some aspect of ISS research. And the fact that we've had that kind of an impact is really amazing.
School children around the world can interact with astronauts and researchers in new and interesting ways by calling crew members on the ISS, sending up experiments and robotics of their own design, and even controlling a high-resolution camera in the Destiny laboratory. While these programs are designed to promote a passion for STEM disciplines, science, technology, engineering, and mathematics in young people, they also illustrate the untold possibilities the ISS holds for the future of education and how lessons can be taught. Beyond its role as an orbiting research laboratory, the ISS also serves as an observation platform, capable of giving us an exceptional view of our home. Unlike imaging satellites with set orbital trajectories, the ISS has a constantly changing view of Earth that enables real-time observation and reporting. Crew members help researchers on Earth track changes in geography and natural formations, observe catastrophic disasters, and document the beauty of nature's phenomena. This bird's-eye perspective of the Earth allows astronauts to map and monitor the world's coral reef and lagoon structures and how they change over time. When a volcano erupts or a tsunami sweeps across the ocean, astronauts have a unique vantage point to observe, photograph, and provide assistance to response teams here on Earth.
There's several things that make Space Station unique for Earth ops. It's close enough so that you can see detail on the surface of Earth if you want to see the detail, but it's far enough away so that you can see things on the length scale of half a continent.
This never-before-seen imagery would be impossible without photographers aboard the ISS, whose images of our home are both scientific and beautiful.
people who explore, people who venture into the frontier, will want to share the experience, and the aspect of sharing what this frontier environment is like to those who don't have the opportunity to go there is a huge factor in motivating the imagery that comes down from Space Station.
As commercial enterprises assume the critical role of transporting crew and cargo to and from station, NASA will focus on destinations beyond low Earth orbit. Research on the station is bolstering our understanding of the challenges in sending a human to the Moon, asteroids, and Mars. The human body is well adapted to life on Earth, but leaving the planet for deep space can have some pretty serious consequences. Research on the ISS helps scientists understand dietary and exercise precautions that will be needed to help fight the adverse effects of long-duration spaceflight. The human body suffers from muscle and bone loss and weakening of the heart and immune system in microgravity. Traveling to Mars also presents the challenge of radiation exposure and potentially hazardous Martian dust, threats that are currently being studied aboard the ISS. In addition to the physical health risks, astronauts also face psychological challenges. Current mission scenarios have travel times of more than 6 months to reach Mars, all while in a cramped environment. Astronauts and cosmonauts spend several months aboard the ISS, which gives researchers an opportunity to study the effects of long duration and closed habitation on human psychological health.
So the ISS is in a gentle environment compared to deep space or compared to a transit to Mars or a near-Earth asteroid. We have to use the ISS while we have it to make sure our life support systems, our propulsion systems, all those things are ready to go the distance to the next generation. And if we use ISS wisely, those are going to make our future missions safer and more cost-effective.
I think the ISS is the greatest human endeavor ever in the history of the world in terms of complexity and the challenges that are brought with that complexity.
Some of the biggest lessons learned from the design, development, and assembly of the International Space Station are those of peaceful cooperation among nations.
It would be impossible for any single country to do what we're doing here on Space Station. But as a team, we're pulling for a higher good, and that higher good is to learn to explore, to learn to push frontiers, to learn to move out. And that's really what cooperation brings us. And I can't think of a better example than Space Station when you look forward.
Humans will continue to explore in low Earth orbit, on journeys back to the Moon, to Mars, to asteroids, and beyond. But wherever we go, the International Space Station is improving our lives on Earth now and cementing our first real international foothold for working and living in space.
This is Mission Control Houston. That is a look at some of the inside of the International Space Station and the science going on board. As we get ready to wrap up, we want to take a look at the video file that's coming up next on NASA television. That'll begin at 11 a.m. Central Time, noon Eastern Time here on NASA television. Of course, we will return tomorrow morning at 10 a.m. Central Time, 11 a.m. Eastern for tomorrow's Space Station Live. We'll see you then. This is Mission Control Houston.